What's up, everyone? I'm here rocking my purple Dragonwing shirt because I'm excited to introduce the Qualcomm Dragonwing IQ 8275 EVK, the newest Dragonwing eval kit from Qualcomm Technologies. The kit is a powerful eval platform built to test the Dragonwing IQ 8275, a powerful processor that delivers industrial-grade performance in a compact and energy-efficient platform. It features an 8-core CPU, up to 40 dense TOPS AI performance, and a dedicated GPU, making it ideal for industrial and enterprise IoT. The processor is also designed for use in extremely harsh industrial environments with a wide junction temperature range of -40 degrees Celsius to +125 degrees Celsius. The Dragonwing IQ 8 series platform is designed for high-performance IoT devices and represents the next tier following our premium Dragonwing IQ 9 series. The EVK also includes 12 gigabytes of RAM, 128 gigabytes of UFS flash memory, a built-in MCU, and a wide range of interfaces and expansion capabilities. You can use the Dragonwing IQ 8275 EVK to quickly prototype and validate AI-powered industrial solutions, everything from smart sensors and vision systems to robotics, drones, and edge gateways. With a single integrated kit, you get everything you need to develop and test AI models, hardware interfaces, and embedded software. You can accelerate innovation and bring your ideas to life faster. Now, let's unbox the kit and see what's inside. The device comes with a bottom enclosure pre-installed, plus a lid that you can install yourself if desired. It makes the kit look a little bit more finished. Let's take a look at the connectors on the device next. First of all, for power, the device supports a 12-volt to 36-volt barrel jack. The kit includes an international power adapter for convenience, along with a Type-C cable and an adapter to the barrel plug. Next, let's take a look at the USB connectivity. On the side of the kit, there's a micro USB connector for the debug UART port, which is used for UART logs using tools such as PuTTY, and it supports automation control. On the front of the device, there's another micro USB port that supports USB high-speed mode in both host or device mode. Note that the device mode is used for ADB on this port if you are using the Qualcomm Linux operating system. Just to the right of that, there's a USB Type-C port labeled USB 0. This is the port used for software downloads and fastboot mode connections to a PC. An important thing to note here, this port, USB 0, is not active once software is booted up. The IQ 8275 chipset does not support simultaneous use of the USB 0 and USB 1 ports. USB 0 is only active in download or fastboot modes. Moving further to the right, there is another USB Type-C port labeled USB 1. This port is host only and connects to a USB 3.2 super speed hub offering 10 gigabits per second bandwidth once the operating system is booted up. To connect a keyboard and mouse to the kit will come with a couple of small micro USB and Type-C to Type-A adapters, or you can use an external hub or any adapter of your choice. It's recommended to use the USB 2 and USB 1 ports here. For networking, the device includes a 2.5 gigabit Ethernet port on an RJ45 connector. There is also a UHS 1 capable SD card slot for storage. The display options include DisplayPort with dual mini DP connectors and a DSI Flex connector on the side. HDMI can also be used by plugging in an external active adapter to one of the mini DP connectors. Please note that if you do provide your own adapter, it needs to be an active adapter, not a passive adapter. For expansion, you'll find a PCIe by 4 connector with an open back to accommodate larger cards running at up to Gen 4 speeds. Camera support is built using 3 CSI Flex connectors. Both CFi and DFi modes are supported. Adapters can be purchased to attach standard Raspberry Pi style cameras. For audio, there's a header that supports stereo speakers and an onboard microphone located along the front edge of the device. The board also includes a JTAG debug header. Now, let's check out the switches on this board. First of all, we have a main on-off slide switch, a software-defined push button, a main dip switch to toggle between download and fast boot modes for both the main domain and the MCU, and several smaller dip switches for rerouting signals to mezzanine boards. For visual indicators, the board includes an orange power LED, a green PS Hold LED, and an RGB user-defined LED. For Wi-Fi and Bluetooth, there's an M.2 slot with the NFA765A module and two coax cables connected to two onboard printed tri-band antennas. Supported bands are 2.4, 5, and 6 GHz. In addition, there are four 120-pin high-speed connectors for routing high-speed signals to mezzanine boards, including PCIe, DSI, CSI, SGMII, DisplayPort, as well as other low-speed signals. We've gone through the major components on the board. Now let's power it up. First, plug in the power and turn on the power switch. To use it as a single board computer, connect a monitor using the DisplayPort cable or the DisplayPort to HDMI adapter. Next, let's plug in a mouse and keyboard into the USB 2 and USB 1 ports on the front using adapters. Recall that USB 0 is only for download mode. If additional USB ports are needed for accessories such as cameras, etc., it is recommended to plug in an external off-the-shelf hub. Connect to Wi-Fi and you'll be able to launch a few sample apps right away by clicking the Q icon. To use it as a hosted device, just plug in the USB 2 port to a hosted PC and bring up ADB. Note that this is only applicable to Qualcomm Linux. Ubuntu requires using the micro USB serial debug port on the side. The device comes preloaded from the factory with Qualcomm Linux. Ubuntu Desktop will also be available for download. To explore all the features of this kit, check out our video using the VS Code IDE. Thanks for watching!